I've given you a zipped folder called Examples Day 1. And within that folder, there are 2 NetBeans projects. This is the first one. And we look first at the syntax of a node. You'll notice that the node has an object and something that's called node. This is actually an address. So the item is an object. That means it cannot be an int. It cannot be a primitive. If you want to put an int in there, then you need to promote it to an integer, the wrapper class. But actually that's done automatically for you. So we have an object and then we have an address. And usually that address is the address of the next node in the list. Here is our constructor. The new item goes into the item, and next is null. It puts the null as the address of the next link. I'm going to not talk about this constructor right now. This is a means of hooking up 2 nodes when you construct one of them, but we'll do that later. Right now, for this example, we're just using this first constructor. So we first make a node. We put a 46 in there. We make another node, we put a 2.6 in there. And we make a third node and we put a string in there, hi. So it looks like this. Now when we draw these things on the board, we put arrows pointing to the nodes, but really, actually, it's the address. So first is the address where we can find this node. Second is the address where we can find this node. And third is the address where I can find this node. But it's easier for us when we're writing these things on paper. It's just easier for us to understand and to draw if we put these arrows. So node head equals first. Always start on the right hand side. The value of the right hand side becomes the value of the left. So first is the address of this node. First is the address of this node that contains 46. Head equals first means that head is also the address of this node. So if you go to the address contained in head or the address contained in first, it's the same thing. You're going to end up at this node. I'm following this code here. I've just done line 17. Now we're on line 18. First dot next equals second. First dot next equals second. So second is the address of this node that contains a 2.6. First dot next is the address that's contained here within first. First dot next. So it used to be null. But what this line is saying is, instead of it being null, put in there the address where we can find this second node. So on the board, we often write that with an arrow because now they're linked. If you go here, it sends you to the next node. Of course, in memory, there are no arrows. This contains the address where I can find this node. This node, incidentally, is not called second. Second is the address where I can find that node. The node has no name. Second dot next equals third. So the address of third goes into the address of second dot next. sorry, the address of third goes into the place called second.next. So the address of third goes into here, second.next. The value of second.next is the address of third. So now I've got them all hooked up. The address of this node that has a 2.6 in is in head.next or first.next. The address of the node that has the high in is in the next of second. I'm going to leave out print list for a minute and move on to line 23. Whoops. Then line 23 I altered after I created this on whiteboard. So it looks a little bit different because this says head 2 and this one just says head. The reason I altered it was because I already had a head up here. So, but the rationale, the reasoning is the same. So we've got node head 2 equals new node 46. Node head equals new node 46. So I create a node, I put a 46 in there. The next will be null, and head contains the address of this node. Or if I like to say it this way, head is pointing to this node. Head.next is new node 2.6. So make a new node, put a 2.6 in there, the next will be null. Head.next is this node. So this is the address of this node. So the address of this node goes into head.next. So if I follow the address that I find in head.next, I will end up at this node. That's where this node lives. It doesn't have a name. There's no other way I can access it except by going to head and then looking for the address in head.next. And then on the third line, head.next.next equals new node high. So I create a node high, and the address of that node goes into head.next.next. Where on earth is head.next.next? So head.next is here. Or rather, the address of head.next is here. So head.next takes me to this address of this node. And then another .next means I go here, and that takes me to this node. So head.next.next. Head.next.next. So on the board we tend to draw arrows, but next contains the address of where we find the next node in the list. I'll just leave this for a minute so you can read this. Okay. So we can do all of this another way. And we look at these lines from 29 onwards. So this is line 29. Node head 1 equals new node 46. So head 1 contains the address of this node with a 46 in it, and next is null. Node cur standing for current equals head 1. So head 1's address is now the address of current. So another way of looking at it or thinking about it is that current is now pointing to the same place that head 1 is pointing. Head 1 and cur both have the same address, meaning they're both the same thing. They both live at the same spot. So head 1 and cur are the same address. Current.next is new node 2.6. So I make a new node, put a 2.6 in there and a null in its next. Current.next, that's the address that goes in here. That's now the address of this new node. In other words, this will tell me where this new node is. And now this is a line that confuses some students. Current equals current.next. You remember current was pointing to head 1. So what do I do with this line here? Current equals current.next. First, I figure out what current.next is. So current.next is this second node. And the address of the second node is now the address of current. In other words, current moved on to the second node. Current equals current.next. We do this over and over again. It moves current over to the next node in the list. Current.next is new node high. Make a new node, put high in there. Current.next now contains the address of this new node. So wherever this new node lives, that now goes into current.next. We didn't move current.next on. We didn't move current on. Current is still pointing to the second node in the list, but we've actually got 3 nodes in our list now. So this is 3 different ways of making a list with 3 nodes. Let me talk a minute about print list here. So here's a print list. It has one parameter, and that's the head of the list. So if you were calling it here, you'd call it here, print list head 1. So here's head 1. So let's see what it does. Node current equals head. So it creates a current, and its address is now the same address as head. So in other words, current would be pointing right here to head 1. And then while current is not null, print out the item. So it would print out the 46, and then current equals current.next moves current onto the next one. So current is now pointing to this one here. And I go to the top of my while loop. While current is not null, it's not null. It's pointing to this. It has a value. It's the address of this second node in our list. So print that out, print out the item, print out the 2.6, and then current equals current.next. So move current on to here. While current is not null, it isn't. It's the address of this body here, this third one. Print current item, so it'll print the high, and then current equals current.next. So right here, current.next is null. So if current equals current.next, current equals null. So now I have kind of fallen off the end of my list, current equals null. And so when I go up here to check it, while current does not equal null, then current equals null, so I'm out of my loop. So I'm out of my loop and I have just printed my three objects in my list. So let's see what we did here. We created a first, a second, and a third. We hooked them all up into a list and then we printed it. If we comment this out, we can run it and we can verify that we printed our list. Then we did something similar, just did it a different way. And printed it. So if I run this again, we'll see our list is printed. Then we used current and print it again, and there we go, printed. So three different ways of creating a list. Usually we will do it this third way. Primarily because, if we have 1,000 things in our list, we don't want to create 1,000 nodes all with different names and then hook them up. So that first way of saying, okay, each one is called something different, that's not good when you've got a lot of them. This one, do you really want to say head.next, .next, 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 .next? That's just inconvenient. It's possible, it's just inconvenient. So using the current is the easier way to go. You start out with current at the beginning of your list, and then you keep moving it along. You don't ever want to move head unless you're trying to delete the front of your list. Because if you lose this head, you have no way of getting back to that first link in that first node in your list. And again, if you're trying to delete the first node, that doesn't matter. But if you're not trying to delete that first node, do not move head. And take some time, play with this, make sure you understand this example 1.